Welcome back to Wood Engineering. I'm Jeff Orochko from Carleton University, and in this video, we're going to talk about finding specified strengths for wood, depending on which way we're loading the wood, and how pieces of wood are graded, so how we know what quality the piece of wood is. First of all, with regard to member size, something that people and probably public don't generally understand is, when you talk about a 2x4, like this piece of wood here, the one on the screen, a 2x4 is not 2x4, right? So in Imperial, 2x4 is supposed to mean 2 inches by 4 inches, right? But in reality, it's not. And there's two reasons for that. And we talked about this in the moisture content video. One is because when I cut the piece of wood, if I cut it at 2 inches by 4 inches from the tree, then there is some shrinkage that occurs. And that shrinkage is significant. And it will start on what we'll call a green size, and then it will shrink down to a smaller size over time. And that shrinkage happens predominantly of the cross-section size. So something that started 2 inches by 4 inches is going to be smaller. Another reason why pieces of wood are smaller than the nominal kind of 2x4 specification is that they smooth out the surface of this piece of wood too. So it's not, right after it comes off the saw, the surface of this piece of wood will be quite rough. So they do plane the sides and round the edges a bit to make these pieces of wood easier and nicer to handle. So 2x4 is not actually 2x4. It actually happens to be 1.5 by 3.5. And I do have a ruler, and you can see in the picture the 3.5. This piece of wood that I actually have here is about 3 3/8 actually by 1.5, or a little bit less than a half. So on top of the actual size being smaller than the nominal, of course we get some variation in piece to piece. So where do I find those sizes? This is a question we get all the time, because it's clear that it's not 2x4, the nominal size, but what is it? So if you have the wood design manual in actually in this volume, volume 2, if you go to the reference section, which is near the beginning of that volume, there is a table 11.5 that actually gives you the sizes of every piece of wood. And I've put those here for lumber. So, here we have a 2x4. And so we can see that that is 38 by 89. And we can also see what the cross-sectional area of that is. I mean, we can easily calculate that. Obviously, it's just 38 times 89, but it also has the I, that's the second moment of area, or what we commonly call moment of inertia, and times 10 to the 6 millimeters to the 4 for the strong direction bending. And it also has the S, right, the section modulus, which we use in our bending equation. So if you need to find those values and you don't want to calculate them, like this is BH cubed over 12, right? This is BH squared over 6, I think, if I recall correctly. Then you can just grab them from these tables. And there's 2x2, 3x3, 4, 5, 6, 3x3, 3x4, 3x6, 3x8, right? 8 all the way up to 8x8. All the way up to 10 by 10 and 12 by 12. So these are all of the pieces of lumber from smallest to largest that are available. Now, actually getting your hands on a 12 by 20 might not be the easiest thing to do. So when you're going into wood design, I wouldn't assume that you'll be able to get that from a lumber yard. Probably you're going to have to build something up if you want it to be that big. But anyway, all the values are there. Okay, so now moving into grading, how do we figure out what the strength of a certain piece of wood is? So when we get it from the lumber yard, it is going to come with a grade. So it's going to say, this piece of wood, it's a certain species group. So it might be, SPF, spruce, pine, fir. And on top of that, it has a grade. So this is a number 1, or it's a number 2, or it's a select structural, which is like the highest grade for this kind of lumber. And depending on the grade, it'll be higher strength or lower strength. And there's multiple ways that they can do that grading. Most common is called visually graded lumber, and that's where kind of number 1, number 2 select structural comes from. So a large majority of lumber is graded this way. Basically, you have like a set of rules. You can have so many knots, you can have a certain grain angle, you can have so many checks, splits, whatever. And then based on those qualitative requirements, you stamp a grade on it, and we assume a certain strength. Now, if you take a larger piece and saw it into a smaller piece, then the grading is no longer accurate. Like if I took a 4x4 and cut it into 4 2x2s, those 2x2s would no longer have the same grade. That's not permitted. Okay, you have to get it regraded if you wanted to do something like that, technically. Another way is to do machine stress rated lumber, which basically means that they take the pieces of lumber, they run them through a machine. The machine bends it a little bit, it pushes it a little bit, it figures out kind of what the stiffness is, and from that it correlates what the mechanical properties are going to be for that piece of wood. And so if you have an automated process where you're building engineered wood products and you're stringent about quality control, that's a thing that you might do, is to use machine stress rated lumber. Like if I'm making, if I'm making wood eye joists or something, then maybe I want to have a fast process to mechanically evaluate each piece. So then depending on grading, I have different strength and I have a different amount of defects. So, the top one here, select structural, this is kind of the highest grade of wood. And then it just goes down from there. So you get number 1, number 2, number 3. Stud grade is kind of the lowest quality. Like maybe this is what you get when you go to Home Depot and just buy something off the rack, and they're all like twisted and warped and stuff like that. So the more defects that you have, the kind of worse your quality of wood is, and you reduce the strength accordingly when you do design. And that's a visual grading process. This is an example of what the requirements are for a certain grade. This is for number 2, structural light framing. So structural light framing is a grade category, and number 2 is a grade. So then you can see, it might be hard for you to read, but it says, well-spaced knots of any quality are permitted in sizes not to exceed the following, or equivalent displacement. So how many knots can you have? You can't have any bark on the piece. You are limited in the kind of splits and stuff you can have. Slope of the grain is a big one because it affects, like if I'm pulling on this, what percentage of the load is going purely parallel to grain, but then a small portion, if the grade is sloped, a small portion of that tension load is going to be loading perpendicular to grain, which we know for wood is a very bad way to load it. So that will affect the strength, for example, and a whole bunch of other requirements. And then once they grade it, they take a stamp and they stamp the piece of wood. Each piece of wood will have a stamp, tells them who graded it, where the piece was milled, what is the species group, like SPF, Doug fir larch, or whatever, and what was the grade that was assigned. So this is a number 1, SPF number 1. And then the stamps might look a little bit different than this, but they should all have that required information. This is the machine stress rating process that I was talking about. So they put the piece of lumber through a machine that has all these rollers. The rollers bend the piece. They measure the load that is applied to bend the piece, which gives them an indication of the stiffness of the piece. And then from that stiffness, they can correlate a stress rating so that they can figure out how strong the piece is and how stiff the piece is. This is what that kind of machine might look like. There's one, so you can see you just feed in the piece of wood from one end, and it comes out the other end, and it'll tell you what the grade is, and then you can put the stamp, or it might put the stamp. I'm not sure. So machine stress rated stamp might be a little bit different. It says that it's machine stress rated. Now we no longer have number 1, number 2, etc. It's actually giving a predicted strength and predicted modulus of elasticity coming out of that machine process. So you can have like a whole set of values for that. And we'll see that when we look at the tables. Okay, so those are the 2 types of visual grading. Now for grading of glulam, it's a little bit different because it depends on what is the composition of the glulam, right? So here are a couple examples for beam grade glulam. And you can see that depending on whether the member is loaded as a simply supported beam, like just sitting here and loaded in the middle like this, or whether it's loaded, as a continuous beam or as a cantilever, so it has stress, it has bending in both directions, we might lay up different pieces when we fabricate the glulam. So the glulam is layers all glued together. So I can change the quality of those layers depending on what my purpose is. So E grade in general, and we'll see this on the in the tables, E grade is meant to be bending in only one direction, and so they're going to put a strong ply just on the tension side because that's going to be the critical side for bending resistance if I'm only bending in the downwards direction. So if I'm only bending like this, for example, I'll put the stronger piece on the bottom. EX grade means that it's in both directions. And so there'll be kind of a standard for this. Now there are numbers in the code for this, but if you are designing with glulam, you should check the manufacturers in your area because they likely have a whole set of different properties that they have for their own glulam because they might lay it up differently. Like they might have their own proprietary way of distributing the strength. Then based on test data, they would come up with their own strengths. But in this course, we're going to only use the values that are in the book. So you can see all of the different grades. So they have ones that are specific in that are intended to be used for beams. There are some that are specifically intended to be used for columns, and there are others that are specifically intended to be used for tension members. You can mix and match. I mean, the columns can take bending and the beams can take axial, but they have a primary intent based on how the layups are. And there are different species as well, and a lot of this will have to do with where in the country you are when you order the glulam. So you might have spruce pine species in the glulam, you might have Douglas fir larch, and you can see that this 20 is actually kind of a measure of the strength. It's kind of an indication of the strength right in the grade marking. So you can see the Doug fir larch ones, you can get higher strengths, and we'll see those in the tables. Okay, so now that I know all about how these things are graded, how do I actually go about finding the strength that I need for my specific equation from the standard that I'm trying to apply? So for glulam, it's quite easy. I just go to the table, and as long as I know my species and grade, I can pick out whatever quality I want. But for lumber, it's a little bit tricky because there are multiple tables for strengths depending on what kind of lumber piece that you're talking about. So the first step is actually to determine the grade category. So this table 6.2.2.1 in the standard is the first place that you would go. And basically what you need to do here is based on the size of the piece and based on the grade of the piece, then you determine which grade category you're in. Okay, so for example, if I have a 2x4, but if this is a 2x4 number 1, then over here, you see my smaller dimension is 2. My higher is the 4, which is 89, 3.5, right? So 38 by 89. So it could be any of these three. Then I said, okay, well, I'm talking about number 1. So I'm talking about this one here. So I am in the structural light framing grade category. Okay, so I need to go to table 6.3.1a. And at the top of that table, it says structural light framing. And so that's where I'm going to get my property values for. You know, like if I have a deep beam that's really big and it's 114 by 200 something, then the smaller dimension's 114, larger dimension exceeds the smaller dimension by more than 51. So if it's 114 by 166 or greater, then I'm going to go to, it's a beam and stringer grade category. So then I have to go to table 6.3.1c, where it's going to say at the top, beam and stringer. Another note is that these are called different things depending on which grade category they're in. All the smaller pieces here, you know, like the 2x and up to 4x are all called dimensional lumber. And the really big boys are called the sawn timber. Okay, so those are like really big, solid pieces of timber. The beam and stringer and the post and timber pieces are called sawn timber. Okay, so then once I know which grade category I'm in, I can go to the appropriate table. This is just an example of one. So this is 6.3.1. So this was structural light framing. So that's where this 2x4 is. Structural light framing, if it's like a 2x4 SPF number 1, then I can find my species. So let's say I'm SPF number 1. And then I can read across here all the different values for strength and for stiffness. So bending, longitudinal shear, compression parallel, compression perp, tension parallel, and my two moduli for my average modulus of elasticity and my 5th percentile modulus of elasticity. Okay, here is table 6.3.1b, which is the one for light framing. So this one has different grades. Okay, so it's also 2 bys, but let's say wherever you are, it's like a different grade. It's not number 1 or number 2. It's graded differently. Then you go to this table. You know, if it's this is a sawn timber or beam and stringer, so this is a sawn timber type of grade. You know, and you can see all of these values are all different for all of these. So there's a lot of work gone into figuring out what are the appropriate values for each of these. So each of these numbers represents a whole bunch of tests. Okay, and you see these tables have a lot of notes on the bottom, some of them, when you go to the standard to take a look at them. Here's one for example. So when I'm talking about beams and stringers, it says below that this table is intended for when the loads are applied to the narrow face. So let's say this is a beam and stringer, so it's a sawn timber, quite a bit bigger than this. But let's say I have it oriented like this. The table there is assuming that you're loading it on the short side, right? Now it says if you are loading it on the long face instead and bending it in this direction, then you have to pick a different, you have to modify your bending strength, and you have to modify your modulus of elasticity as well. So pay attention to those notes. There aren't a lot of them that change a lot. Most of them are kind of warnings, you know, be careful to season the wood properly so that it's for sure dry and all this stuff. But that's one for sure that, you know, you never know could come up. Okay, and then this is the last one, which is for post and timber. These are for the ones that are more square. So basically the cross section is square or close to square. They're probably going to be columns, posts, right? And so these are all the values for those, and you know, a ton of notes. Okay, and here, you know, it says, just like I was saying, designers strongly advise to check availability of species, grade, and sizes before specifying. So you're going to go through a lot of trouble and make a timber design, and then find out when you go to when the contractor goes to build it that there's no way they can get that size of a piece of wood, and then you're going to have to go through a rigmarole, and there's going to be construction changes, and it's going to cost the owner money, and they're going to be upset, and then you're going to be upset. So just be aware of what's available in your area as you do the engineering. So we're not engineering in a bubble, obviously. Okay, so then that was for all visually graded lumber. For MSR lumber, there's a table for the machine stress rated stuff. You can see the grades. We saw these in the grade marking. This is a strength and a stiffness combination, and then they have values as well. I'm not going to specify these kind of members in this course, but you know, if you ran into something like this, then this is where you would get the values. There's table 6.3.2 for that in the standard, in the O86 standard. Now, when I'm doing Glulam, it's a bit easier because I no longer have to go to a grade category. All I need to know is the species and the grade. So if I know I'm going to use Douglas fir larch 20 FE grade, then I can find my bending moment, can find my shear, I can find my compression parallel resistance, compression perpendicular resistance, all of the required resistance, including modulus of elasticity, are all in this table. These tables, it's a bit funny that these ones are flipped relative to the other ones. So the other ones had the strengths on the top and the grades on the side. This one has the grades on the top and the strengths on the side. So anyway, I'm sure you're going to figure it out. So that's for Douglas fir larch species. This table continues down a bit further for 2 other different species combinations, spruce, lodgepole pine, jack pine, which in this course I'll just call spruce pine, and hem fir and Douglas fir larch combination here. You can see the effect of the different layup in this table. For 20 FE, remember that E is the one that's not symmetric, so it has a stronger piece of wood on the bottom of the glulam. You can see that the bending moment in the positive direction is larger than the bending moment in the negative direction. So you can apply negative moments to those, but they won't be quite as efficient as if I use the 20 FEX grade, which has the same strength in both directions because it's got strong plies on the top and on the bottom. Okay, so I'm just going to finish this off by showing a few examples of how to go through that process. I'll point a few things out, won't take very long. So I'm going to find the strengths for these three different pieces of wood. One is a 2x4 SPF Select, that's Select Structural. And I want to find the compression resistance parallel to grain. So how do I do it? I'm going to start by figuring out what the size of my member is if I don't already know. So a 2x4, going to this table 11.5 in the wood design manual, and I see that it's actually 1.5 inches by 3.5 inches, which is actually 38 by 89. So now I know the size of my piece of wood so that I can go to my grade category table and figure out which grade category I'm in. So smaller dimension was 38. That's the 2, it's a 1.5. The larger dimension was 89. So actually there are 3 different options here for grade categories that will work, right? So it could be light framing, could be stud, could be structural light framing. But I also had the piece of information that I'm talking about select grade. So that's select structural grade. So that's not available in light framing or stud grade categories. It's only available in structural light grading category. So I know that I'm talking about structural light framing grade category for this particular piece of wood, 2x4 SPF Select. So now that I know it's in structural light framing, I know I have to go to table 6.3.1a, where at the top it says it applies to structural light framing. And then I know I had SPF Select, so I go to Species, SPF, Spruce Pine Fir. Grade Select, SS means Select Structural. And I want to find compression resistance parallel to grain, so that's this column. And so I read down at the intersection that my FC, parallel to grain resistance for this piece of wood, is 14.5 MPa. And that's what I'm going to put in my equation when I'm doing my calculations. Second example, larger piece of wood, 10x12 Douglas fir larch number 2, looking for a longitudinal shear resistance. So I'm going back to table 11.5 to figure out what the actual size of that piece of wood is. So I've got a 10x12, which is actually 9.5 by 11.5. So I have a 241 by 292. So going to my grade category table, I know I'm 241 by 292, so small dimension 241 is only these 2 possibilities. 292 is the larger one, exceeds the smaller dimension by 51 or less. Okay, so how much does it exceed? 292 minus 241 is 51. Okay, this says 51 or less. Okay, so this is right on the border. Okay, you'll notice this one says exceed smaller dimension by more than 51. So that means 52 or greater. I don't know why they didn't put this a little bit higher to make it a little bit more obvious that this one would fall into this category. But anyway, so it's 241 by 292, 51 or less. So it falls then into post and timber category. Okay, one because it fits here, it's a number 2, so that's good. Post and timber. So now I have to go to the table for strength, 6.3.1D, which is the post and timber grade category table. And I know I have a Douglas fir larch, number 2, and I'm looking for longitudinal shear. And the reason I picked longitudinal shear here is because some people get confused by the fact that there's only one number in here, and these are blank. This 1.5 applies to all grades. So it just means that the longitudinal shear is the same for every grade of Douglas fir larch. So even though I'm down here, the 1.5 applies. Okay, so my longitudinal shear for my Douglas fir number 2 is 1.5 MPa. Last one is a Glulam example. So I have a spruce pine 20 FE Glulam beam. I'm looking for positive and negative bending strengths. Okay, so the first thing I need to do is go to that table 7.3 and find out which species I'm talking about. So this is spruce pine. So it's not the top part of the table, it's the bottom part of the table. Spruce, lodgepole pine, jack pine. So I'm going to use the lower part of this table now. Okay, this is just that lower part blown up. Spruce, lodgepole pine, jack pine, 20 FE grade. And I'm looking for bending moment positive, bending moment negative. And here you see I have a positive of 25.6 MPa and a negative of 19.2 MPa. And this is one of those cases where it's different. And that's because this is not a symmetric layup pattern. So the bottom ply is only the strong ply and the top one is not stronger than normal. So now we know how to specify wood properties. We know what the grades mean. And so hopefully now when we dive into doing design for tension, design for compression, when we need to find those strengths, we know which tables to go to.